Hi everyone. Students often come to me and say that they have difficulty in solving those problems of trigonometry which involve proving some relationships using trigonometric identities. So I've made this video for those people. Okay? Let's take this example. Cosec theta minus cot theta the whole square is equal to 1 minus cos theta divided by 1 plus cos theta. This has to be proved. Whenever you have these kind of problems, first thing you need to decide that which side to start with. It makes sense to start with that side which is having more number of terms, because reducing the things is easy. If you have to expand the things, then you will have to add too many terms from your side, which will be always difficult. So in this case, we will start with the LHS. The left hand side is equal to cosec theta minus cot theta the whole square. Now, invariably it is easy to convert any of these relationships in sin theta and cos theta and then try reaching to the RHS. So in this case, let's try. This is 1 upon sin theta minus cos theta upon sin theta the whole square. Now each step when we move, we need to also think whether we are reaching closer to the RHS which we have to prove. Now in this case, you can see that the RHS is having cos theta, and whatever conversion we have done, at least one term of cos theta is appearing. So there is a possibility that we will be able to reach our destination. Okay. What weapons we have to solve these problems? Weapons are these trigonometric identities. Sin square theta plus cos square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Or cosec square theta minus cot square theta equal to 1. We can also use these relationships. Sin theta is equal to 1 upon cosec theta, cos theta is equal to 1 upon sec theta, and tan theta is equal to 1 upon cot theta. Let's move forward. So we can do this. Sin theta, and this becomes 1 minus cos theta the whole square. As I said that at each step you need to check whether you are inching closer towards the RHS which has to be proved. Now what we are finding is here it is 1 minus cos theta, and here also it is 1 minus cos theta. It means we are reaching closer to what we have to prove. And it also indicates that we need to work more on that term which is not appearing in the RHS. So how do we do that? Let's take the next step. This becomes 1 minus cos theta the whole square, and the lower term can become sin square theta. Now I have to play with this so that the square term goes. So it is only 1 minus cos theta into the numerator, and denominator I need to get 1 plus cos theta. So the next step would be that I need to then write it as 1 minus cos theta the whole square divided by 1 minus cos square theta. Because sin square theta plus cos square theta is equal to 1, therefore sin square theta will be 1 minus cos square theta. Now I can use algebraic identity because this is in the form of a square minus b square. So I can write it 1 minus cos theta the whole square divided by 1 minus cos theta into 1 plus cos theta. Now we see that 1 minus cos theta can cancel the square, and therefore this becomes equal to 1 minus cos theta upon 1 plus cos theta, which proves the RHS. So this is one way of proving this relationship. There is another way of proving that relationship. And again, we will be using the same fundamentals which we had talked about. Start with where there are more number of terms. At each step, you need to see whether you are reaching closer to your goal, and the weapons which you will be using to reach to the goal are these combinations of equations and identities. Okay, so let's try another way of solving this. Now, we see that there is a cosec theta term and cot theta term. So, which of these trigonometric identities will have cosec theta and cot theta term? This is the identity. That means that if I use this identity, I may be having some kind of combination which creates a situation where some cancellation can happen and I might be reaching closer to my goal. Let's try that. We know that we can write this as divided by 1. Why introduced 1? Because this identity is showing me 1. And therefore, I can then use cosec theta minus cot theta the whole square divided by cosec square theta minus cot square theta. Now again it is in the a square minus b square form. So I can write cosec theta minus cot theta the whole square divided by cosec theta minus cot theta and cosec theta plus cot theta. Because this one is in a square minus b square form, so I can write a minus b into a plus b, which helps me getting rid of this square. Now I get a relationship where it is cosec theta minus cot theta divided by cosec theta plus cot theta. If I convert now into sin theta and cos theta form, then it will be 1 by sin theta minus cos theta divided by sin theta. And in the denominator, I can write 1 upon sin theta plus cos theta by sin theta. If I just take the LCM, then it will be sin theta and this will be 1 minus cos theta. And here again I take LCM in the denominator and this will be equal to 1 plus cos theta. Now sin theta and sin theta will get cancelled and therefore we reach to 1 minus cos theta divided by 1 plus cos theta, which was the RHS to be proved. So this is another way of proving the same relationship. Now if suppose none of these hit to you, okay, then we can go to even more basic of solving these problems and we can change this equation into algebraic equation form and then try proving that. So let's give it a try. So we know that any right angle triangle, by the way, all these trigonometric ratios are defined with respect to a right angle triangle. So suppose there is a right angle triangle, is ABC. So this is the hypotenuse. And if this angle you are taking as theta, then this becomes base and this becomes perpendicular. Now I know that cosec theta is defined as hypotenuse by perpendicular, and cot theta will be defined as base by perpendicular. So I can write it this way. And then I can take this LCM. So this becomes h minus b, and this is the whole square. Okay. Now I can write this as h minus b the whole square divided by p square. I also know from the Pythagoras theorem is that hypotenuse square is equal to base square plus perpendicular square. So from that I can write this as h minus b the whole square divided by p square will be equal to h square minus b square. Again it is in a square minus b square form. So then I can write h minus b the whole square divided by h minus b into h plus b. And again a square is gone. So I can write this as h minus b upon h plus b. And if I divide the numerator and denominator by h, I can write it this way: h minus b upon h and h plus b upon h. Because if I divide the numerator and denominator with same quantity or number or variable, then there won't be any change, right? So then h by h will be equal to 1 minus b upon h divided by 1 plus b upon h. Simple division. Now we know that base upon hypotenuse is cos theta, and therefore we can write this as 1 minus cos theta So using this, then we can also write that this is nothing but the RHS which I had to prove. So there are three ways we solved this one problem.